Hello, this is the seventh video out on the Network Dummy channel, and today we'll be going over OSPF, or Open Shortest Path First. OSPF is an important concept you should understand if you intend to pass your CCNA. This is the network topology we'll be working with in this video. We'll be working with 6 routers in today's video. As you can see here in this problem statement, there is only one question you have to solve here to complete this exercise. Question 1. OSPF is partially working in this topology. Router 1, 2, and 6 are correctly configured. Router 1 has no knowledge regarding the network highlighted in blue. Diagnose the error in this topology. Like the previous exercise, you should first try to solve it yourselves, and if you can't, that's alright, I'll give you the answers right now. Just to get things out of the way, the process ID is not the reason for OSPF neighbor failure. In OSPF, the process ID in the same area does not have to match up. This is however different from EIGRP, which is another type of dynamic routing protocol. In EIGRP, all process ID should be the same, but we'll skip over that for now. Let's go over question 1. Just to prove that router 1 has no knowledge regarding the network highlighted in blue, I'll use the command do show IP route in the configuration of router 1. As you can see here in the routing table, there are 2 OSPF routes registered. However, the routes known to router 1 does not include the destination network address of 192.168.45.0, which is this one here, and 192.168.34.0, which is the route here. Its routing table only extends from router 1 to router 3 and router 5, but not to router 4. To diagnose errors regarding OSPF in this exercise, you need 2 commands, which are show IP OSPF int and show IP OSPF. Now that that's out of the way, let's diagnose the error. Since router 1, 2, and 6 are correctly configured, let's move our attention towards router 3, 4, and 5. We'll start off with router 3. First, we'll go on to the CLI tab and use the command N to go to admin configuration mode. And then we'll use the first command, show IP OSPF int here. As you can see here, there's a bunch of text here that might seem confusing from the get-go, but once you've understand OSPF, it'll get easier. For this router, let's focus our attention towards the hello and dead timer. The hello and dead timer can be found right here. The default hello and dead timer should be 10 and 40 seconds respectively for an OSPF broadcast type. Just an additional reminder, the hello and dead timer is not always 10 and 4 for OSPF, especially if it is a non-broadcast OSPF network type. But in this case, it is 10 and 40 seconds. A mismatch will result in OSPF neighbors not being established. Now let's move on to router 4. Again, I'll go to the CLI tab, I'll go to admin configuration mode, and then I'll use the command show IP OSPF int. The problem with this router is that the OSPF area is incorrectly configured, as you can see here. If you've noticed from my previous show IP OSPF int command on router 3, you would realize that the OSPF area being used in this topology is area 0. This, however, is an OSPF area 1, which is the source of its error. Moving on to router 5. Let's try the command show IP OSPF int here. As you can see here, the command show IP OSPF int does not work here. I'll attempt to use the second command, which is show IP OSPF. This command shows this result. The important thing to understand here is that router ID overlaps with router 1. As you can see here, routing process OSPF 5 with ID 1.1.1.1. And that overlaps with the loopback ID in router 1. As you can see here, the loopback ID here is 5.5.5.5. However, in terms of determining the IP address for OSPF, the router ID comes before the loopback ID. So even though I assigned loopback ID of 5.5.5.5 here, because I've manually assigned the router ID to router 5, which is 1.1.1.1, that takes precedence over the loopback address. Because there's an ID overlap, This is the source of error of router 5. You cannot have the same address in an OSPF area. In this video, we've discussed that hello and dead timer mismatch, OSPF area misconfiguration, and router ID overlapping causes neighbors to not be formed in OSPF. Here are some other reasons as to why OSPF will not be formed. Network type mismatch. Specifically, there are 5 network types in OSPF. However, in the CCNA, you only need to know 3 of these: broadcast, point-to-point, and non-broadcast. Another reason why OSPF neighbor failure might occur is because of MTU mismatch and authentication mismatch. Also, I've just added something new. Subnet misconfiguration is also a reason why OSPF neighbor failure might occur. So in a single OSPF area, they should all be in the same subnet for it to work. And that is it for the video today. If you've enjoyed the video, please make sure to like and subscribe, as that would massively help the channel. Thank you very much and have a nice day.